Let's look at another example of hypothesis testing. It says a report stated that 31.9% of babies are delivered by cesarean section. A researcher believes that this percentage is less than, or that the percentage is less than 31.9% in a large hospital. The researcher randomly selected 50 newborn infants and found that 13 were born by cesarean section. At alpha 0.1, is there enough evidence to support the claim? Okay, one of the first things you need to do is look at this and recognize when it gives you ratios like this, 13 out of 50, or percentages, you are actually doing the formula with p hat. Now this is the formula that goes along with proportions. Okay, so it is z equals p hat minus p over square root of p times q divided by n. So we're talking about p hat minus p over square root of, and then on the bottom, notice it's all square root, p times q divided by n. So this formula is what they call the z again. We're going to talk about the z distribution again. But you need to remember from previous sections that p hat, that is the sample. P belongs to the population. So in this particular one, let's go up here and identify what we have. P is going to equal 31.9%, so I'm going to put 0.319. Now p hat is going to equal 13 out of 50. And I do want to make that a decimal. Sometimes they round 2 places, sometimes they round out 3. They're not consistent in this textbook, but that would be 0.26. Next thing I want to point out is that n is equal to 50. Our sample size is 50. So that means we're using the z distribution. Now if you look at this formula, in previous examples, different chapters, we needed q hat. In this case, we don't. We do need q though. So you are going to have to solve for q. If p is 0.319, q is equal to 1 minus p, which is 0.319. Whoops, I'm running out of room here. Okay, let me erase that and fix it. So we are going to subtract that 0.319, and we find out that q is equal to 0.681. I think we have everything we needed to start, so let's go over here and let's say step 1, our hypothesis. H sub 0. Now because we're doing proportions, this time we use a p instead of a mu. P equals 0.319. And then h sub 1, this time it is less than. Remember, you're looking for either less than, differs, greater than. This one is a less than, 0.319. And that is the actual claim. They are claiming right here that it is less than. So I'm going to write claim right there. Now for step 2, let me drag in a curve since I'm not very good with drawing. Let's drag in our curve here. And for step 2, when it is a less than, it is left-tailed. Remember, less than is left-tailed. More than is right-tailed. Equal and not equal to are two-tailed. Since it is one-tailed and we are in the z distribution, I would put my alpha in the tail, which would be 0.01. Next step is going to be to get the critical value. Remember, we're using the z distribution because our sample size is greater than 30. I'm going to add 2 zeros to this because you guys know from previous examples that chart has 4 digits. It is easier to look it up if I have 4 digits. So let me pull up the table. I believe it is this one. We are in the z distribution. We are on the left tail, so we are on the negative side. Now remember, this chart is left-tailed. Our picture is left-tailed. So I just have to look it up. I don't have to do 1 minus. When our chart is shaded to the right, I have to do 1 minus. So we're going to look up the closest thing to 100 in this chart, which would be right here. 0.99 is the closest thing. This is 2 above, this is 1 below. Go to the closest. That happens at negative 2.33. So our critical value is negative 2.33. So let's go back and let's put that on our chart. So for step 2, critical value equals negative 2.33. Now we are ready for step 3. Step 3 is our test value. Let's get a different color here. Step 3, test value, and we wrote down the formula over here. Okay, so I'm going to lower that just a little bit since I've got that formula over there. This formula was for the z equals of a proportion. That is our step 3. So let's come down here and put 3. Test value. P hat is 0.26 minus P, which is 0.319, over square root of P, 0.319, times Q, 0.681, and that is divided by the sample size, which is 50. And when you plug that, that's a divided by right there, by the way. Sorry, it's kind of messy. Divided by 50. When you plug that in, you get negative 0.895. This thing doesn't like to do decimals. All right, so we got negative 0.895. Let's go see where that would fall. That would fall somewhere right in here. It's closer to 0 than negative 2.33. So that would be my negative 0.895. And now we are ready for step 4 and step 5. Hopefully you guys, you've done these enough. You're getting really good at these. So for step 4, we look at the white area. This would be the null. Okay, step 4 is always about the white area. Your answer is to reject the null or do not reject the null. When it is empty, you reject the null. When the white area is not empty, then we do not reject the null. We don't want to reject it because it's not empty. Step 5 is about the claim. Go back up here. Did they claim the white, the null, or did they claim the alternative, the shaded? Go to the shade because they claim the shaded. Go to the shade. Is your evidence there? No. The green line is your evidence. Okay, and that green line is not there. So there is not enough evidence to support the claim. So there's not enough evidence at alpha of 0.01 to support that it is actually less than. And that would finish this problem.